Okay, thanks for your patience, ladies. I'm going to try to show you these last two at the bottom here. I'm going to start with 15. And of course, hopefully with these calculators, you'll be able to get this. All right, so starting with 15, starting at the bottom on this page, I'm going to start with this one being kind of easy because it gives me two of the angles inside that triangle. So I know if I add those up and take those away from 180, it gives me what that angle has to be in there. So that would have to be 57. So for this one, pretty easy because I have all three angles right away. Angle A 57 because that's what it needs to be added up to get 180. This is 38, and then B is 85. To find my angles though, I can't use basic trig because this is not a right triangle with that right angle in it. That forces you not to be able to use simple sine, cosine, tangent. You have to use this identity formula right here. So what I'm going to do to find my pieces here, to find A, let's set it up like, oh, looks like I have piece C right here is 12. So let's write that one down. So I'm going to go from C because that one gives me a length to start. So that's why I'm choosing C to start with. And I'm going to just use the sine identity formula. Sine of that angle C, sine of 38, that angle's 38, over the length of side C, 12, equals the other piece I'm trying to find. So maybe how about find angle, or piece A would be sine 57, because I know angle A is 57, but I don't know piece A. That's A right there. To solve this, again, these are crisscross multiply. When I times this way, I get sine 38 times that variable A, and then when I times the other way, I get 12 times sine 57. So technically right there, I'm going to divide by sine 38, and that will give me what piece A is going to equal. So here I go, doing all that work. Hopefully my calculator works. 12 times sine 57. And again, I've got to put that parentheses because I got to make sure I times 12 and sine 57 first before I divide. So parentheses, 12 times sine 57, close that parenthesis, and then divide that by sine 38. That should give you A is about 16.3. I'll go to one decimal place. And now to find that last piece, which is this little piece B right here, I could either do sine of A, because now I know what piece A is. So I could do sine of A over 16.3 equals sine of B over B, or I could do sine of 38 over 12 equals sine of 85 over B. Does not matter. So to solve this one, I'm going to come in from angle C, setting it up like this. Sine of 38 over side C, that's sine of angle C over side C, and of course side C is 12, so put a 12 right there, equals the other one I'm looking for, sine of 85 over little piece B. And again, looking at this, you're going to times 12 and sine 85 and then divide it by sine 38 right there. So if I do that to solve for B, B is going to equal 12 times sine 85, and I'm going to divide that by sine 38. That will give me B right there if I do that correctly. So 12 times sine 85 divided by sine of 38. That equals about 19.4. All right, to find my perimeter, all I have to do is add up those three numbers. So 16.3 plus 19.4 plus 12 gives me about 47.7. To find the area though, I'm forced to use this guy right here. So first find S. S I get by adding all those pieces and dividing by 2. That'll give me what S is first. So here I go. 16.3 plus 19.4 plus 12 equals 47.7 divided by 2. S equals 23.85. And then, of course, A is 16.3, B is 19.4, C is 12. Here I go. Area equals the square root. Put that S number in there, 23.85. And then another 23.85 minus the length for A, which is 16.3. And open up another parenthesis with that same S number, 23.85, minus the B number, 19.4. Open up another parenthesis, that same 23.85, minus the C part, which is 12. And I'm going to square root that whole mess. So here I go, square root, double parentheses here, 23.85 times 23.85 minus 16.3 times 23.85 minus 19.4 times 23.85 minus 12 gives me about 97.4. And I'm hoping I did that accurately. Again, area is not a degree. All right, here we go. 14. All right, so number 14, again, I had to use this gnarly one right here. And the reason I use that is because this one has me solving for b squared right there, b squared by itself. And this one starts with me having the angle and b. So that's where I'm starting with this one. I have b I'm solving for. I have that angle right there of cosine b. I have my lengths for a and c. This is a right here. This is c right here. All I got to do is plug those in. All right, so here I go. To find that angle, b squared equals a squared. A is 15 plus b squared is 20 squared, I believe, plus 2 times a times c times cosine 124. I am square rooting this whole madness piece to get what b is. Good luck. All right, here I go. My calculator spits out 15 squared plus 20 squared plus 2 times 15 times 20 times cosine 124. I get 17.01, or just plain old 17, I call it. So B is, I think, 17. A is 20. A is 15. B is 17, and C is 20. To find my angles, angle B is 1 124. Now to solve for those other angles, now I'm going to use the trig identities, the sine identities. So here I go. If I do sine of 124 over what b is 17, that's going to be equal to one of my other angles. How about sine A? Don't know what A is, but I know what piece A is 15. So again, when I crisscross this one, I get 15 times sine 124. And on this side, I get 17 times sine A. So technically, I need to divide by 17 right there, this whole mess. And then I'm going to inverse sine it. Inverse sine. And that should give me what angle A is. We'll see. So here you go. Double parentheses. 15 times sine 124 divided by 17. Let's try that again. Inverse sine 15 times sine 124. Let's do it again. Inverse sine double parenthesis 15 times sine 124 divided by 17. So I get about 47 degrees. And now to find that missing one, I'm not going to do that ever again. I'm going to add 47 and 124 and take that away from 180. Gives me about 9 degrees right there. Thinking that might be a little bit low. Let's just double check that 9 right there. So if I do 9, let's use the formula. Let's go sine 124 over side B 17 equals sine C over 20. So this is going to be inverse sine of this whole mess over here. It's going to be 20 times sine 124 divided by 17. I'm going to inverse sine this. So you can see why you don't want to do the angle this way. It's better just to add them up, subtract from 180. Inverse sine. So that didn't give me the same S. Let's try it again. So inverse sine 20. I get 77. What happened? Let's do that other one again. Yeah, that one gave me 47. Let's try this one. Yeah, this is giving me C is 77. I'm not sure what I'm doing wrong right there because they should equal 180. Oh man, I gotta double check that one. But the perimeter, add those up. And then the area, like I said, use this problem right here. Maybe this little extra video will help you. I hope it does. Good luck, good luck.